Okay, we're back, and this is part 2 of the video of the most common problems. We said before the no heat problem is mostly, it could be electrical, the control is not running correctly, something wrong with the aquastat, the thermostat, and we will do a lot of troubleshooting for hot water systems when in combustion control circuit. But as you know that the power from B1 and B2 in the aquastat goes to the uh, primary control, so make sure you at least check the power for that, check the TT terminal and the voltage on the T terminal, that's 24. And okay, that covers the electrical part. So the electrical part will go to the aquastat, thermostat, or CAD, primary CAD control, and we can check that using a multimeter or a series of troubleshooting in the wiring. Another problem is the swishing around when the water turns on. This is a very common problem. We hear that a lot. And that means that there's a problem with the air separator and there's small little bubbles that are accumulating in the system. And it could also be a leak in the system. Check the air separator function. How do we do that? You can take it apart and look at the valve that is opening correctly, and you can use a little compressor air to blow in the dirt that accumulated in there. Purge the system. That's another issue. You can replace the entire amount of water in the system and get rid of any dirt in the system that can be trapped in the lever inside the air separator. Check for leaks. If you have swishing, you must have air. If you have air, then you have leak. So that could be a problem, but not necessarily the main issue. You can hydro test the system to make sure there is no leak. What is hydro testing? Hydro testing is when you connect a pump, an air pump, to the system, and you pressurize the air inside the system to make sure and leave it on. So you connect the pump and a pressure gauge and make sure the pressure gauge does not drop. If it drops, that means there is a leak in the system, and it will make it easier for you to find the leak if you pressurize the system and go and follow and see where there is some kind of leak. Of course, you will check mostly fittings, connections, and radiators. If the system is not giving enough heat, make sure, okay, this is also another issue. Is the water temperature adequate? Check the high limit in the aquastat. Check the high limit, make sure it's set correctly. Make sure the circulator is working. If it's working, there is not enough heat, could be dirty radiators. This is one of the most neglected parts. People do not understand that radiators have to be cleaned, and I'll show you some pictures about dirty radiators. If we have a radiator that looks like that, probably you have lost all the heat surface inside those little uh, sheets of aluminum, so the air is not circulating properly, and probably there's blockage, so the air is not going inside. So these has to be cleaned periodically, especially if you have a lot of animals or they are placed in a place where there's a lot of dust and debris. If they're also crooked or bent, so probably they're not giving enough heat. Probably it's not going to be as bad as the other one because the other one looked very clogged. But this is also a bad radiator. It has to be replaced or cleaned or at least straightened out. And those are very thin. You can straighten them with a small chisel or a screwdriver to make them straight and wash them or power wash them. Again, it's very difficult to clean those, especially when they get to this stage because they are connected to the pipe. So you could at some point replace the entire pipe where you have disconnect this part and the other part in the other side and replace the radiator, but that's again a very costly repair. So maybe power washing, and also if you have a steam washer, those actually do work miracles on those radiators, so you can wash away all the dirt and oils that is stuck to the radiator. Okay, another topic, boiler failure. If the boiler failed, probably means it cracked, right? So the boiler is basically a chamber with a radiator with a heat exchanger on top of it. So if it breaks or start leaks, could be old, it could be the low water cutoff did not work, or there could be the boiler is higher than the radiators, which means it did siphon some water and run with low water and cause it to break. So when the radiator breaks, so it could be uneven heating, and uh, it run with low water eventually cause the material to fail. A lot of time we have a retrofitted boilers, or which means like a coal or wood boiler been retrofitted to work with gas or oil, so that could be a problem. That system has not been balanced correctly, and we have a lot of impingement, and that causes the walls to overheat, and eventually they will crack. Corrosion, another issue. Heat exchanger also eroded over time. Sediments, time, age, those are all can cause you to have failure in your boiler. So low firing temperature, combustion problem, clogged vent, inadequate chimney flow, all these aspects can cause you to have corrosion from the outside. What does that mean? What does the outside mean? Let me explain to you. If this is my firing chamber and this is my flue pipe gas, they're going through a heat exchanger all the way the flue pipe outside, and I have water running from one side to another. This is considered the outside, and this is here is the inside. So if it's running from the outside, it's got to be a water problem. So it's from the outside. The condition is taking place in the vent. So if the low firing temperature, combustion problem, clogged vent, inadequate chimney flow is coming from the outside, which means here in this area. Actually, it should be from the inside. So if it's created from the inside in here, that means there is a flue pipe coming back. I will fix this. It's from the inside. If there's low temperature and there's a condensation problem and bad combustion problem, this will cause the pipe to be corroded from the inside. If it's from the inside of the boiler, which means inside of the boiler, which is here, this part, it is a water problem. So I'll consider this terminology. This is the outside of the pipe, and this from the inside of the pipe. I think it's just reversed in here. Water hammering is usually in steam boilers. So check all the pipes are pitched correctly, 10 degrees. So we don't want more than 10 degrees or less than 10 degrees. So if this is my steam radiator, this is my pipe, and this is my boiler, you want 10 degrees. If it pitched too much, then you have the condensate flowing too fast, and then cause you to have water hammering. If it pitched too little, the water can stay in here and not move as fast. So you can again have some water hammering as well. So again, sometimes it's a trial and error for pitching the pipe. So you try it out, you pitch it, then you listen for the hammer, then you go again. And again, there's a lot of variables that plays with the water hammering issue. It's how insulated the pipe is. It's the temperature outside in the room, the temperature of the steam. All these factors play within the pitching of the pipe. So if the system, most steam systems are installed long time ago, but if you install a new pipe or a new section of a steam system, don't be frustrated if you didn't get it right the first time. It is a lot of trial and error. So condensate and steam should not flow in the same direction. That makes sense because we have our pipe here, and usually the steam goes this way and the water will go in the bottom. Pipe reducers can cause puddles. I will show you in the picture what does that mean. The type of reducers and pipe fitting make a difference when it comes to steam. Drip traps should be located in all zone valve. So for stream valves, if you have zone valve for steam, you want to have traps, steam traps. Pipe should be free of clogs. No clogs are allowed in steam system. Water quality is very important. Should be free of oil or dirt. If you have oil, then you have foam. If you have foam, then you have blockage, and that blockage can cause you to have water hammering. Again, water hammering is one of the most common problems with steam. It's very frustrating, but again, eventually it happens. Uh, Again, we're still in the steam and water hammering, so they say the pH should be less than 9.5. So neutral is 7. So if you have 9.5, that's mostly caustic. Less than 7, it's acidic, so it can cause deterioration. So you want to have neutral water, somewhere between 7 and 9.5. So again, if the boiler should not be oversized. If the boiler is oversized, it's going to produce too much steam, and if that happened, and you're producing too much steam, then the EDR rating for each radiator, then you will have more condensate and you'll have issues with the circling of the steam inside the system and can cause you to have water hammering. So again, this is the case when you want the system to be sized correctly. It should not be 10% than the total house EDR. Again, because we are trying to balance the amount of steam we're producing and how fast do we make condensate, and if we have too much condensate than steam, then you will have a lot of flows in different directions and cause you to have hammering. Water should be within the design limit. If not, it's going to hammer, so you have to drain some. Do not overfill the system. If you have hammering in the mid-cycle, like let's say you just turn it on, it started giving off heat and started to hammering, probably you have a system that is overfilled. Radiator should be pitched toward the condensate drip line. Makes sense. Radiator vent could be the problem. If that vent is not functioning, then probably it is not letting air out, so that will throw off the system balance and you will have some more steam generated in the system, and you probably will have some water hammering. If the vents are not working correctly, then air can go back into the radiator if the system has shut off, and that will cause you to have water hammering after you shut down the system. So you have something in the mid-cycle, end of the cycle, and beginning of the cycle. Beginning of the cycle is when you have too much water in the system. Okay. So if you look at those, this is kind of the analogy inside the pipe. What happens? Steam goes in, water comes back. The water is in the bottom. This is steam. And what happens if you have too much water? You have a wave, and you will have a pocket of steam in here that eventually will try to find its way, sneak its way through the water, and eventually cause you to have a small bang and hammering. Reducers and connections. You want to avoid to have this kind of connections because this is an area where you will have some kind of water accumulation. So that's not a really good idea to have this kind of tilts and accumulation of water, because they do cause you to have some hammering again, and hammering happens whenever you have water pocket meeting the steam. And again, if you've noticed now, the steam velocity and the water velocity also do come into play when it comes to water hammering. So this is some of the connection that you want to have. If you want to have an expansion or contraction, it's better to have the tilts or expansion from the top, and those fittings are designed for steam for that purpose. So we will eliminate the accumulation in the bottom of the pipe. This is an example of a water separation, a water steam separation trap. So this is the air separator, and it's where we have the steam coming from the top. Air vents will come from the vent over here, and the rest is condensate. Okay, I will pause now and I will continue in the third video with hot forced air problems and some other issues we might have in heating systems.